4 light bulbs are concealed from an observer by an opaque wall as shown. Without shifting the positions of the observer and the bulbs, how many bulbs can the observer see from the mirror? So what's going to happen is that the light from your bulbs is going to bounce off the mirror, and if it bounces off the mirror at the correct angle, it's going to enter the eye of your observer, and your observer will be able to see it. So depending on which bulbs these are, the angles are going to be different, and the observer may or may not be able to see your bulbs. So we are nicely given a figure that's drawn to scale. We can actually make use of that to figure out which bulbs can be seen by the observer. So what I've done here is that I've drawn in 2 light rays using angle of incidence equals to angle of reflection. And these light rays, basically, you'll notice that they are barely touching this opaque wall here. And what they represent are the extreme angles to which your light can still go and still enter the eye of the observer. So I use this trick where if light can come from an object and reach this point, then light can also come from this point and reach this point. So that allows me to draw the rays starting from the eye and going at different angles instead of trying to draw the rays starting from elsewhere and reaching the eye. So basically what happens is that if I have a ray that's going at a wider angle than this, then what is going to happen is that if the ray starts out here, so it's going at a wider angle, then it's just going to hit your wall and it's going to stop. It's not going to be able to make it through. So any light ray that is further than this, so any light coming from this side onwards, it won't be able to make it past the opaque wall. So same thing with light that is at a narrower angle than this ray over here. So instead, I'm going to have my light ray being something like this, and then as it bounces, it's going to end up bouncing maybe like this, and it will also run into my opaque wall. So any light that comes from this side onwards of this ray also won't be able to make it into the observer's eye past the opaque wall. Remember, if light can come from an object over here and reach the observer's eye, then light must also be able to come from this point and reach the object over here. But we already have decided that it's not possible. What can happen is that light from anywhere within these 2 regions, well, they can bounce off the mirror and reach the observer's eye without being obstructed by the wall. So that's the light from lamp A, lamp B, and lamp C. So how many bulbs can the observer see from the mirror? Well, there are 3 of them. That's going to be our answer.